Hello everyone, welcome back to my channel. Today we are going to pick the second problem, which is an remove element from the top interview 150 series from LeetCode. So in this, what we are given is we are given an integer array, which is nums, and an integer value, which is val, and we need to remove all the occurrence of val in this num, and it should be an in-place algorithm. The order of the elements may get changed, then return the number of elements in num which are not equal to value. Okay, so basically we need to remove these elements, value elements from the num, and it should be an in place. Okay. Now considering the number of elements in nums which are not equal to val, it should be k. So we need to do the following things. We need to change the array in such that the first k element of nums contains the elements which are not equal to value. Okay, and the remaining are not important as the size of nums. Okay, so we just need to return the size of k, which is the elements which are not value. Okay, so this is just in custom judge. So in this, they are writing their algorithms and going to test their algorithms against us. So this is a remove element. So we will be calling this. So we will be getting a k value, and they will be sorting it. Okay, and then they will be checking that. So let's take the first example. And so we are giving this nums. Nums is an array. Value is 3. So the output is 2. So they have removed this 3 and 3. Okay. And in this function, this value is 2. So they have removed 2. So 0, 1, 3, 0, 4, 2. Okay. So your function should return k equal to 5, which the last first 5 elements number containing. So how should we proceed with this? So if we take the first example, so they have directly substituted the value. Like they got 3, they substituted with 2, and then they again got 2, and then they again got 3, and that got substituted. But if we check the example 2, so in this they have picked 0, which is a non-value, so 0, then 1, which is a non-value, then 2, and which is a value. So they, instead of putting 3, they put 4, and then they again substituted it with 0, and then they got 3. So in this they have used the two pointers approach, where they started from here, and where once they found a value, then they check from the end, which is a non value element. Now since they are using the sort mechanism, so if we want to just close this, so we can just substitute the value, because they are going to sort it anyway. So if just to solve it, we can use this, in which we will be checking every element, and if the value is not equal to value, so then we will be just put in the value. And since j is only going to proceed where the values are not present, so just we can return this j. Now if we run it, and if we submit it, so this will pass because they are using this sort mechanism. And apart from that, they have also mentioned that they are not uh, going to what's the remaining element of nums are, and they are also not going to check uh, like the order of the elements. But if we want to check this second approach, Now to check the second approach, so where they are substituting this value, so then we need to do some modification. So the first modification is we will be declaring some variables. Then we are going to do some transformation and then some end use case. Now to declare this some variables, so first variable which we will be needed is the size. Then we will be needing the start and end index. Then an index and the result. Now this result is what we will be sending. Now after this we have declared these variables. So now we will be starting with the for loop. Now we are going to check if the nums of I is equal to value. Now if we check that, then we need to do some transformation, which is we are going to start from end until they are greater than or equal to I. I is the current index. So then we will be proceeding with nums of I with the nums of n. And we do the n minus minus. Okay. And there is a condition. If nums of n is not equal to value. Like if the value we are substituting is again a value which is a value only, so there is no need to substitute. So only then we will be proceeding with the substitution. Now for this after this swap we will be break out of this loop. Now else we just do the end minus minus. Now once we found an element which is like a position where end is surpassing this I, then we will be looping out from this while loop and then we can send this rest. Now to update this, so let's say the value is not value, so the current element will be rest plus keys. Now these will check. So let me check if it is for this for loop. So in this we will be checking if the value is not equal to value, then that means it's a correct value. So just we will be putting this rest plus plus. Now the end use case is we will be returning this rest. Now if we submitted code, okay, we forgot to put. Now if we check, the value is 2, 2 and 2. Now the for the case 2, it is also 101403 as required, right? Now if we submit it, so we have it got pass accepted. Now if we check, now this approach is a two pointers approach. Now if we check that out of these, we are still not needing this for loop. Like we can substitute this for loop also. Uh, like if we check if start is less than equal to end, and we are not going to use this index. Now if we check that this value, the nums of I is equal to value, so we can check substitute it with start. Now for this I we can substitute it with start because we are just checking the current index, and then we will be checking, and then if we found something we substitute at the start only. Apart from that, then if the condition is not, like the value is not, the start value is not value, then we just proceed forward. So from for loop we have transformed into a while loop. Now the complexity, what is the complexity going to be? And if we submit it, so the complexity which is going to be, okay, so now it's like above average code. So now the complexity is big of n. Why big of n? So we will be checking the element, and we will be checking the element from the start. And if the value we found is actually and value which we want to remove, then we check from the end. Now once that end element is traversed, we are not going to traverse it back. So it will be an big of an approach. We have just substituted it with while loop from for loop, and that has helped us to remove the complexity from big of n log n to big of n. That's all for the current video. Thank you everyone for watching this video. Let's see you everyone in the next video.